So our lesson for 4.6 inverse trig functions is going to have to be split amongst 2 different days. So this is 4.6 part 1, where we introduce the basics of the inverse trig functions, arcsine, arccosine, and arctangent. And we'll talk about how to evaluate different parts of the unit circle using arcsine, cosine, and tangent. Now, you're going to have to sit through a very rough rendition of me trying to graph some of these functions here at the beginning. So luckily there's some really nice already drawn computer-generated graphs that we're going to be looking at. So what we have here is an example of a sine function. And remember, when we worked with inverse functions back in the day, we said that if a function has an inverse function, then it is a one-to-one function, meaning it passes the horizontal and vertical line test. But if I look at the sine function, while it does pass the vertical line test, it would fail the horizontal line test, which tells me that the inverse of the sine function is not a function. However, if we were to restrict the domain and only look at part of the sine function, then we could interpret what we have there and find the inverse of just that portion. And we're going to see what we call the arcsine. So here they restrict the domain starting at negative pi over 2, and then they end it at positive pi over 2. And if we just look at that part of our sine function, that would be a one-to-one function. It would pass both the vertical and the horizontal line test. So another thing to remember about inverse functions is they are reflections of each other over the line y equals x. And it's going to be a little hard for me to graph this in here, but pretend that was the identity function y equals x. If I were to reflect that over that line, we'd end up with this curve here. And this is the inverse of the sine function, also known as the arcsine function. So, sorry, I had a visitor. Okay. So on the next screen, this is referring to some other components of inverse functions. So remember, the original function for sine, if we restrict the domain from negative pi over 2 to pi over 2, that is how we're going to restrict the range. Because remember, our inverse functions have domain and range that have been switched, which mean the original range for sine now becomes the domain for arcsine, negative 1 to 1. So that's what this screen is kind of summarizing for us. The next screen is playing off of your notes paper. So if you have the notes paper, you might want to get that out. And then you're going to have to sit through my attempt at drawing a little bit of arcsine here. So knowing what I know about inverse functions is if I'm going to restrict the domain, negative pi over 2 to pi over 2, that means my range is going to be that for my inverse, or my arcsine. So this is negative pi over 2, this is pi over 2, and then my original range for the sine function was negative 1 to 1, which means my domain goes from negative 1 to 1 now. And then this is going to be real great. Ready? We're going to attempt to draw in the reflection of this curve that I just highlighted in black there. So the starting point is going to match up and the ending point is going to match up, but that was so bad. You know, I re-recorded this lesson because I messed up. But the first time I did it, it was actually not really bad. This is pretty bad though. Okay. Use your imagination. If I go back a couple screens, this is what it was supposed to look like. That's the shape of the arcsine function. So it does have a little note here about we must memorize where arcsine is defined. Same thing with arccosine and arctangent. I'm going to give you a little bit of a cheat sheet though. It looks like this, and we're going to use some markers. We're going to highlight who is defined in which parts of the unit circle, which quadrants. So right now we just determined that arcsine is only defined from negative pi over 2 to pi over 2. So if you have a marker, you would kind of mark this up here. And you would write something about arcsine being that blue marker. And then, you know, while we're at it, if we're looking at our class paper, we might as well just go ahead and mark up all the rest of them. Arctangent is going to be defined in the same places. Let's do arctan. But arccosine, we're going to find out in a moment, is defined from 0 to pi over 2, to pi, excuse me. That's not a very good job. Hopefully you're using 3 different colors there. And that's a little reference page that we're going to be using a lot of. Okay, so what we're going to do now, we're going to evaluate different inverse trig functions at various locations. But remember, we're using the unit circle. If you have this handy, keep it out. This is the inverse sine of the arcsine. So they're asking me within the given domain, so for arcsine it's just the quadrants 1 and 4, where does sine give you an output value of square root of 3 over 2? So if I go back there and I look at just these quadrants, the sine has an output of square root of 3 over 2 right here. And remember, we're only allowed to look at quadrants 1 and quadrants 4 for arcsine. So if I want the radian measure for that, that'd be pi over 3. This next question is asking us if we apply the inverse sine of the arcsine to negative 2 pi. Now, don't be confused with this question. The sine of negative 2 pi does not equal arcsine of negative 2 pi. These are two different questions. So at first glance, a kid is going to look at the unit circle and think about where negative 2 pi is and try to evaluate sine there, but that's not what it's asking. So negative 2 pi is negative 2 times 3.14, so it's like roughly negative 6.28-ish. So they're asking me, when does the arcsine give me an output of negative 6.28? Yeah. So it doesn't, right? Because, or sorry, I should say give me an input. Because it's restricted between negative 1 and 1. So negative 6.28 is far beyond the negative 1. So we're going to say that that value is undefined or does not exist or something like that. And, a lot of kids are very dependent on their calculators on these questions, and they might put their calculator in radian mode and then use inverse sine. That might give you a little bit of a direction on these questions to see, like if you're on a multiple choice test, you might be able to figure something out. But we have to be careful about using our calculators because it only gives us one value. We'll talk later about why that's a problem. All right, so here, arcsine, inverse sine, negative 1. So if I look along where I highlighted in blue here, my sine value coming out to a negative 1 on the unit circle right there. So that's at, remember we're calling this in radians, that would be negative pi over 2. Oops. Okay, so I think I kind of learned my lesson about maybe I'm not the greatest person to draw these inverse functions. What we have here is a cosine function, and they highlighted a very important part of cosine function because they're going to restrict the domain of the original cosine function between 0 and pi. So just like with sine, we restricted it from negative pi over 2 to pi over 2. Cosine is restricted in a similar way. They're just shuffling it over a little bit because they need to make sure that whatever they're left with is going to pass the horizontal line test. Therefore, the inverse would still be a function. So that's where they're going to restrict the domain for cosine, which means that is now going to be the restriction for the range for arc cosine. So notice the range is from 0 to pi, and then thank goodness they went ahead and did this graph for me because mine would look really, really, really bad. So we're just going to take this visual, and I'm not going to graph this one by hand if you don't mind, because obviously my graphs are terrible. So I'm going to skip this step where we try to graph it by hand. But if you haven't already marked up your circle, remember we marked up arc cosine being defined between 0 and pi. So when I go to answer these questions about inverse cosine or arc cosine, I'm only allowed to look on the unit circle between 0 and pi. So keep that in mind. So if you haven't already done so, please mark this guy for arc cosine. All right, let's do this. So arc cosine, negative square root of 3 over 2. So looking at just these quadrants, inverse cosine producing negative square root of 3 over 2 is right there, and that would be 5 pi over 6. All right. Then arc cosine of 2.5. Well, that's not going to happen because remember cosine was only between negative 1 and 1. So it does not exist. Or you can say undefined, whatever makes you happy. All right, arc cosine inverse cosine of negative 1/2. Looking in the proper domain, negative 1/2 for cosine is right there, and that would be 2 pi over 3. I think having that little color-coded unit circle with the defined quadrants is really, really, really helpful. All right, and then just for fun, might as well talk about arctangent while we're at it. So again, I've learned my lesson. I'm not even going to bother hand graphing this for you. Here is the tangent function. And if we restrict the domain from negative pi over 2 to pi over 2, what's left in the middle there is going to pass the horizontal and vertical line test, so that will be a one-to-one function. And I can create an inverse function, and then once again, the domain and range swap, just like they have been. So thank goodness someone went through and graphed this for me, because you know I'm not going to be able to. So here's our arctangent, or inverse tangent function. And we're supposed to draw it by hand, but I'm going to skip this step. Maybe in class I do it, and you guys can all giggle at my terrible graphing. So on your little cheat sheet here, we already knew arcsine was defined between negative pi over 2 and pi over 2, but now arctangent is also defined between negative pi over 2 and pi over 2, so make sure that's marked up as well. And then we have to remember that the tangent is sine over cosine. So it's a little unfortunate because when we have this lovely unit circle, tangent is not there. So if you want for your homework, even though it's not great practice for your test, if you want to kind of off to the side, at least in the first quadrant, to write out what the tangent will come out to, just to kind of get your brain thinking about what the fraction would be. Remember, if we take sine and divide it by cosine, square root of 3 over 2, dividing fractions is multiplying by their reciprocal, so multiplying by 2 would give you the square root of 3 for tangent. Okay, here the tangent would come out to 1. Here the tangent originally would come out to 1 over square root of 3. But remember, we'd rationalize that, and you'd get square root of 3 over 3. So forget that. And then here, 0 divided by 1 would be 0. And then here, 1 divided by 0 would be undefined. Alright, so I just did the first quadrant coming up with tangent. I kind of wrote it off to the side, but you can continue on down to quadrant 4 if you'd like. My fellow teacher here already went through and marked off the negative values, just in case you had trouble with coming up with the coterminals that were negative. So we're going to keep coming back to that screen, but I should mark up somehow that arctangent is only going to be using these two quadrants. I know you guys already have that marked down on yours. Alright, so arctangent negative square root of 3 over 3. So for my work earlier, I saw that tangent is square root of 3 over 3 here at pi over 6 radians, but I want it to be a negative tangent. So that would end up being his, right here, negative pi over 6. Alright, and then inverse tangent negative 1. Again, back to the unit circle, I can only look at these two quadrants. This guy gave me a tangent of 1, so this one would be negative 1. So remember, we're using the negative pi over 4 version, that coterminal. Okay. Alright, so this screen just kind of summarizes everything we just talked about, shows you the differences between arcsine, arccosine, and arctangent. Notice the, we didn't talk a great detail about this, but the range of tangent was not restricted in any way because it went along the asymptotes. So similarly, when you have arctangent, the domain is not restricted, because remember, they reverse. So something in red here that seems important. You must eventually memorize domain and range for each of the functions. Essentially, you need to remember who is defined where, and that will help you. You'll understand that, I can't find, like we had the example of arccosine of, something much larger than 1, and we realized that that didn't exist. So there's certain ones where we just have to remember that it's not going to exist, so there's no point in us trying to find it. We'll talk more about this later, especially when we do our second part of trig. Alrighty, where are we at? This example here, I don't think it's on your notes, but it says arcsine or inverse sine negative 1/2. So remembering that we have to be in these two quadrants for arcsine, and then looking at our unit circle and thinking about, okay, well, it would have to be down in quadrant 4, so we'd have to find the trig value that gives us a sine at negative 1/2, and it turns out it's negative pi over 6. So I'll be honest, guys, if you don't have a unit circle in front of you, it might take a little bit of effort and work. You can start with the calculator and try to get some information from that. But really, if you just sketch it out, I think you'll figure it out. I know no one wants to remember the unit circle, but it's just one of those things we use so much that we end up memorizing it. Alright, so here's a much prettier version of arccosine is defined in quadrants 1 and 2, and then sine and arctangent are going to be defined in quadrants 1 and 4. And we have to remember that down here in quadrant 4, we're measuring from negative pi over 2. So that's why she has the additions of these negative coterminals down here. Alright, these are just some extra practice problems. So, arctan 0, if I go back a screen, remember tangent has to be quadrants 1 and 4 here. So, tangent coming out to 0 is sine over cosine. So, like right here, tangent is 0. So, it'd be 0 radians. Arc sine square root of 3 over 2. Remembering sine is in these quadrants. So where is the sine square root of 3 over 2? That's right here. So that'd be pi over 6. Arc cosine coming out to square root of 2 over 2. So going back a screen. Can't use this one because it's negative, but over here, there's the cosine of square root of 2 over 2. Cosine function giving you square root of 2 over 2. So that's at pi over 4. And then arctan, negative 1. So arctan negative 1 would have to be one of the 45's family. Or I was going back to degrees, my bad. The pi over 4's family. And if I need it to be negative 1, that would be down here at negative pi over 4. So there's a lot more examples here. All right, let's keep going. I think we're close to the end of the lesson. I think what comes up next is just a bunch of practice problems. So, let's keep at it. Alright, how far are we? Okay. Arc sine, negative square root of 3 over 2. So going back to my unit circle, looking in the proper quadrants, I want the sine to be negative square root of 3 over 2. Let's get that thing out of the way. And I already forgot what I'm finding, arc sine, right? So here we go. There's negative square root of 3 over 2, and that would be at negative pi over 3. Alright, I'm going to kind of jump around a little bit. Let's look at number 10. So right away I'm a little leery of that one because I feel like we've seen one where it was undefined, and we think about arc sine coming out to negative 2, and I look at how my sine and arc sine functions are defined because of the restriction, and this does not exist. Or you can say undefined. Or abbreviate undefined in some way. I'm going to skip around a little bit. Alright, so here, I think we're still in the first part of the lesson. We're going to have compositions of the functions coming up here, and I actually think this is going to take us into the second part of the lesson. So I'm going to pause the video. Everything that follows this is going to be 4.6 part 2, the rest of the inverse lesson.